Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on February 11th, 2026, about 6 days ago. It proposes a major shift from simple semantic matching to what the authors call agentic exploration, revealing that leading models achieve only about 29% exact match accuracy when facing complex, context-heavy retrieval tasks. The paper is titled DeepImageSearch, Benchmarking Multimodal Agents for Context-Aware Image Retrieval in Visual Histories. And, as we'll see later, the gap between traditional retrieval methods and this new agent-based approach is quite dramatic. And for those interested in the implementation, the authors have shared their code on GitHub. To understand the core problem, Figure 1 illustrates how retrieval paradigms have evolved. At the top, Panel A shows direct image retrieval, where a model simply matches a query like yellow cat to a relevant image based on visual similarity. In the middle, Panel B depicts reasoning-intensive retrieval, which adds a layer of logic, such as deducing a jersey number from external knowledge, but still evaluates each image in isolation. Finally, the bottom panel introduces DeepImageSearch. Here, the model must first scan the visual history to find a contextual clue, like a specific event logo, and then use that context to locate the target photos, which requires reasoning across the entire corpus. So, Figure 2 breaks down the two specific query types this benchmark uses to test those reasoning skills. On the left, intra-event queries require a vertical drill down. The model must first locate a specific event, for instance, identifying a concert using a background logo, and then filter images within that event to find shots of the lead singer. On the right, inter-event queries demand a horizontal scan across time. Here, the agent searches through multiple trips to find a recurring object, such as a statue seen twice in 6 months, which forces it to compare details across completely different folders. Creating these complex queries manually is impossible at scale, so Figure 3 presents the semi-automated pipeline the authors developed. It begins on the left with visual semantic parsing, where models analyze images to extract structured details, like person attributes. Next, latent association mining finds hidden links between these items, for instance, spotting that a statue in one photo matches a statue in another. These verified connections feed into Stage 3, building a memory graph that maps relationships between photos and events. Finally, on the right, a large language model traverses this graph to synthesize the text queries and reasoning paths. So, Table 1 reveals how well current state-of-the-art models actually perform on these complex queries. The upper section lists closed-source giants like GPT-4 and Claude Opus, while the lower section covers open-source challengers like Qwen3VL. The results are sobering. The top performer, Claude Opus 4.5, only achieves an exact match score of roughly 29 to 32% overall. A closer look at the columns shows that inter-event queries, which require scanning across long timelines, generally yield lower scores than intra-event ones, confirming they are the harder task. Well, to better understand the scale of the challenge, Figure 4 details the dataset statistics for DeepImageSearch. The metrics at the top reveal a massive search space of over 109,000 photos from 57 users, where each query targets roughly 4 specific images. The chart on the left confirms a balanced test ground, split almost evenly between the intra-event and inter-event queries we defined. On the right, the thematic distribution shows that while portraits and people dominate at 42%, the dataset also heavily features nature, daily items, and architecture, ensuring models must handle diverse visual content. Alright, moving from dataset stats to model failures, Figure 6 breaks down exactly where these agents go wrong. We see pie charts for 4 top models, including Claude Opus and Qwen3VL, categorizing their error types. The massive blue slices reveal that reasoning breakdown is the dominant failure mode, accounting for roughly 36 to 50% of all errors. This means the models often understand the context, but fail to execute the necessary multi-step plan. The yellow sections highlight that visual discrimination is the second largest hurdle, where agents struggle to distinguish fine details like specific attributes. Wrapping up, the clear takeaway is that standard semantic matching fails when context is distributed across time. The low scores on the new DSBench benchmark demonstrate that future retrieval systems must evolve into active agents capable of reasoning over entire visual histories. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.